Hi there, welcome to Shimadzu Asia Pacific channel. My name is Desmond, a LC application chemist. Today, in this video, we'll learn about different ionization interface for LCMS and which interface to use for analysis. There are many different types of ionization interface used for mass spectrometry. However, two of the most commonly used ionization interface for LCMS are electron spray ionization interface, in short ESI interface, and atmospheric pressure chemical ionization interface, which is also known as the APCI interface. ESI and APCI are soft ionization techniques that can generate protonated ion in positive mode and deprotonated ion in negative mode. We will start off with the working principle of ESI interface. Let's look at the design of ESI interface. Sample solution from HPLC will enter the ESI interface from this position. After that, the sample solution will travel downwards and reaches the ESI probe where the ionization will occur. Here is a cross-sectional picture of a heated ESI probe. Heated ESI probe has heating gas introduced which allows faster evaporation of the droplets, thereby increasing the ionization efficiency. Now, we will proceed to learn about the working principle of ESI. Ionization with ESI start off with electrical neutral sample solution from the HPLC entering the ESI capillary tube. When the sample solution reaches the tip of capillary, a high voltage is applied on the sample solution. This will generate a fine mist of charged droplet with the same polarity. The charged molecules within the droplet spread across the surface to minimize column repulsion. As the droplet undergo dissolution, the repulsive force on the droplet surface will increase. Once the repulsive force exceeds the liquid surface tension, the charged molecules will be liberated into the gas phase and enter the mass spectrometer. Common applications that uses ESI interface for analysis are screening of residual pesticide, analysis of veterinary drugs, and analysis of peptide. Next, we will proceed on to the working principle of APCI interface. In APCI, sample solution from HPLC is first vaporized by spraying it into a heater with nitrogen gas. Let's take a look at the design of APCI interface. Sample solution from the HPLC will enter the APCI interface from this position. After that, the sample solution will travel downwards and reaches the APCI probe and corona needle. This is where ionization of APCI will occur. Here is a cross-sectional picture of APCI probe. Sample solution is vaporized by spraying it into a heater before reaching the corona needle. Now, let's move on to learn about the working principle of APCI. In APCI, sample solution from HPLC is first vaporized by spraying it into a heater with nitrogen gas. Vaporized molecules would then hit the corona needle, triggering a series of reactions. Solvent molecules are first ionized by corona needle. After that, a proton transfer reaction occurs between the solvent ion and the sample molecules. Then, dissolution occurs leading to the generation of sample ions. Lastly, the generated sample ion would then enter the mass spectrometer. Some of the common applications that uses APCI interface for analysis are analysis of nitrosamine, analysis of antioxidants such as chlorophyll and carotenoids, and analysis of phenols and its derivatives. Now that we understand more about ESI and APCI interface, let's learn how to select the interface to achieve best analysis result. Below is a simplified diagram showing which ionization interface to use for analysis with respect to the target analyte polarity and molecular weight. In general, ESI is the most commonly used interface for LCMS, as it can ionize most of the analytes. In cases where the target analyte is not easily ionized by ESI interface, APCI interface can be an alternative solution. There are situations where simultaneous analysis of analyte that can only be ionized by ESI interface and analyte that can only be ionized by APCI interface is required. To address this issue, Shimadzu have developed dual ion source interface, in short, DUIS interface. As the name suggests, DUIS interface allows ionization of analyte using ESI and APCI techniques concurrently. Let's look at the design of it. Sample solution from HPLC will enter the DUIS interface from this position. After that, the sample solution will travel downwards and reaches the ESI probe, where the ionization with ESI technique will occur. Sample solution that is not ionized will continue downwards to hit the corona needle. This is when ionization with APCI techniques will occur. Here is a zoom-in simplified diagram of DUIS interface design. Now, let's take a look at the analysis of 3 vitamins with ESI, APCI, and DUIS interface respectively and compare the result. The vitamins used for the analysis are vitamin B1, a cationic water-soluble vitamin, vitamin D2, a neutral fat-soluble vitamin, and vitamin B2, a neutral water-soluble vitamin. When the analysis is done with ESI interface, good signal intensity was observed for vitamin B1 and vitamin B2. However, low signal intensity was observed for vitamin D2. When the analysis is done with APCI interface, good signal intensity was observed for vitamin D2, but weak to no signal was observed for vitamin B1 and vitamin B2. From the result, it shows that ESI interface is good for analysis of water-soluble vitamin, while APCI interface is good for analysis of fat-soluble vitamin. Next is the analysis done with DUIS interface. Good signal intensity was observed for all target analyte, vitamin B1, vitamin B2, and vitamin D2. With DUIS interface, analysis of water-soluble and fat-soluble vitamin can be done simultaneously. To summarize, ESI interface is the most commonly used LCMS interface, and APCI interface is more suited for non-polar compounds. In cases where target analytes are not easily ionized by ESI interface, APCI interface can be an alternative solution. Lastly, for simultaneous analysis of polar and non-polar compounds, DUIS interface may be the ideal interface to use. That's all for this video. Thank you for watching, and we'll see you in our next video.
Excellence in science. Shimadzu.